The eye of the beholder. Neither mantis nor shrimp, but with a name that encompasses each, stomatopods make up more than the sum of each both their namesakes. Words by Gary Holter. My first interaction with a stomatopod, those creatures that live in the public imagination under the name of mantis shrimps, came not during some diving expedition off a pink-sanded Caribbean island, but a rock pool on a rainy afternoon during a holiday in Devon. I was a child, and like all children, I was fearless, sticking my finger into holes and crevices without any thought of what might be living inside. It was probably a Platysquilla eusebia that got me, but at the time I didn't even know what a stomatopod was. I certainly learnt what it could do, though. Many of you will wonder if there really are mantis shrimps in British waters. The answer is yes, but they are rare and in many cases locally extinct. Why so? Well, like so many ecological problems, the cause is man. The Victorians loved their seafood, and unfortunately the British stomatopod species provided them with a perfectly edible scampi. Just as we see with so many other marine species today, this overfishing led to the eventual collapse of the fishery. For exploitation meant nothing to those making large sums of money until there was nothing left to catch. Today, to find any stomatopod in British waters requires immense luck, scuba gear, or the knowledge of a fishing skipper prepared to pass on locations where they might be found. There are areas that form part of marine sanctuaries where they might be found, but they really should be left alone. Stomatopods are part of the phylum Arthropoda, subphylum Crustacea, subclass Hoplocarida, armoured shrimps. They are part of the biological classification known as the Malacostraca. There are 5 superfamilies, 17 families, 100 genera, and over 450 individual species spread across tropical, subtropical, and even temperate seas. A few are even found at the frigid seas of the poles. They are all aggressive and territorial apex predators. They are all aggressive and territorial apex predators that have evolved a unique raptorial limb used to attack prey. This design of the limb further divides the stomatopods into spearers and smashers, something we will return to. Despite the name, they are not true shrimps, having broken away from lobster-like ancestors about 400 million years ago, with a raptorial limb first appearing in the fossil record about 250 million years ago. They range in size from 18-inch or more monsters like the zebra mantis, Liosquilla maculata, to diminutive species less than an inch in length. Stomatopods are visually akin to lobsters, being elongated and often elaborate in form. They have a head with stalked eyes and antennae, a short thorax and a segmented abdomen. The body usually terminates in what is usually a particularly well-armoured telson or tail. So tough are some telsons that military science has looked at their structure to improve body armour for soldiers. The thorax carries 8 pairs of limbs, and these are used to manipulate prey, signal to other stomatopods, move food to the mouth, dig, and more. The second pair of limbs are the ones that give stomatopods their common mantis shrimp name, looking as they do like the unique limbs of the terrestrial praying mantis. Behind the raptorial limbs are 3 pairs of maxillipeds, or manipulating limbs, with 3 pairs of walking limbs or pteropods behind them. The abdomen carries the gills, reproductive organs, and 5 pairs of swimmerlets, pleopods. Some species are especially gaudy, likely as a warning to predators or to attract mates, while others are cryptically coloured to avoid predation. Smaller species are often taken by octopus, cuttlefish, and fish like triggers or groupers, creatures with the hardware to deal with the tough shells and tougher telsons. Within species, different sexes carry different colours, which can lead to misidentification issues. Weaponized shrimp. The raptorial limbs fold up so that they lie under the head and thorax, the folding allowing the stomatopod to cock the gun by means of a locking action controlled by muscles contracting against the lock. Once the lock is released, the contraction of other strong muscles blasts the raptorial limbs forward in an explosion of speed. Top tip: Lego blocks to make a great target, especially if the smell of the food inside leaks out. The speed of the strike will come as a shock. The locking process stores up massive amounts of potential energy, which allows the stomatopods to possess one of the fastest actions found in the animal world. An action capable of clean blasting a crab to bits, or giving a human a significant shock. Not without reason do fishermen refer to them as thumb splitters. The impact of the strike is amplified by a shock wave generated by the collapse of the cavitation bubble created by the speed of the movement. And what of the legend? Can stomatopods break aquarium glass? From personal experience, I can assure you they can and they do. Even with such dangerous tools available, stomatopods try to avoid fighting, preferring to run away and fight another day. To avoid fighting, many stomatopods have developed a visual display known as the Merrill display, the use of which is often enough to see a submissive individual retreat. In this, they adopt an aggressive posture, heads up high and ready to strike with their limbs, to the extent that the two pronounced Merrill spots on the top of each attacking limb are put on display. However, strikes during combat can lead to body parts being knocked off or severely damaged, enough to render them useless. And this is not a problem for stomatopods, as they will tear off useless limbs and replace them as they shed their exoskeletons, much like crabs and lobsters will regrow limbs after an accident. Stomatopods, like all crustaceans, have to shed their exoskeletons to grow, and limbs and even eyes can be replaced in as few as 4 months. Considerations for keeping a mantis shrimp. To keep a decent-sized peacock mantis, Odontodactylus salaris, or several smaller mantis shrimps, you should aim for the following: an aquarium with a footprint of at least 90 cm per side and a depth of at least 40 cm. A sand bed of at least 7.5 cm should be provided. Rockwork can have things like corals because they carry little interest for your shrimp. Rocks should be supported in a way that they cannot collapse as the stomatopod digs and shifts his or her home about. Acrylic tubes of about 7.5 cm diameter buried under the rocks might see your stomatopod take up residence, but this is no guarantee. Lighting should only be bright enough to see your shrimp, but if you are going to keep corals with the stomatopod, light the aquarium for them too. Water needs to be moving all the time and well oxygenated. Protein skimmers are advised, as are calcium reactors and all of the usual marine aquarium hardware. They might be tough, but mantis shrimps are still susceptible to poor water. Food should vary in type, but do not overfeed. Aim to offer small meals 3 times a week. When feeding, always use tongs and never feed by hand. Avoid feeding live prey such as crabs just to show off the punch of your smasher, as this could result in injury to the mantis shrimp. The aquarium must be kept covered the aquarium must be covered as much to keep fingers out as to keep the stomatopod in. Children should keep a safe distance. Once established and given the right levels of care, your stomatopod should be long-lived. 20 years is not unusual and a source of great enjoyment. Top tip. Due to the spatial requirements of large species such as squilla, I don't recommend attempting to keep them in a domestic aquarium, even a large one. Spear or club. Earlier I mentioned spearers and smashers, and some of you may be wondering what I'm talking about. Just seeing the difference in the raptorial limbs between the two types should give you a good idea, although how the raptorial limbs evolved and diverged into 2 distinct forms is a whole different matter. It's something a budding evolutionary biology student could spend a lifetime researching. The raptorial limb shape indicates not just the style of hunting technique a stomatopod employs, but often gives a clue to the type of habitat it might be found in. Spearers need a clear space above them as a strike space, an area without that isn't shaded that allows them to catch the soft-bodied prey they prefer. To facilitate this, the spearers are usually found in large expanses of sand, such as a lagoon floor. Spearing stomatopods dig burrows of considerable size, often with several entrances, and sometimes share their burrow with another stomatopod. Some spearers form monogamous, lifelong relationships where the male hunts for prey, the female looking after the eggs. The male shares his catch with his mate. This is extremely rare in crustacea and similar life forms. Spheres have a differently shaped eye that found on a smasher. Spheres have a differently shaped eye to that found on a smasher, and it may well be the shape of the eye that allows them to identify suitable prey without risking injury from taking on either too big or an aggressive species. Smashers inhabit areas where sand and rocky outcrops are located, so areas such as Back Reef. Unlike the spheres that wait to ambush passing prey, smashers actively hunt hard-shell crabs, clams, and other bivalves, and even cowries. Crabs and similar animals represent a significant risk to the stomatopod, given that they can and do fight back. Small smashers hunt at dawn and dusk, where an element of surprise works to their advantage. As they grow larger, smashers can be found hunting in all light conditions, with glitter lines often confusing prey species. Unique beasts. All stomatopods have extraordinary memories, being able to find their way back to their home burrow even after a hunting trip that may have taken them meters away. They can remember where competitors might be and even where potential predators might lie in wait. But memory is a minor feat as compared to their wondrous eyes. Stomatopods have seen significant scientific investigation by researchers. Alas, being restricted by word count, I can only touch on some of the key points. Stomatopod eyes adhere to the standard crustacean compound eye structure, but each eye is divided into two distinct hemispheres, separated by a third section known as the midband. The eye is composed of multiples of individual mini-eyes, called omnatidia. The upper and lower hemispheres provide straightforward vision. The upper and lower hemispheres provide straightforward vision, given over to identifying form and shape without the use of colour. We might consider the hemispheres as high-definition black and white cameras for purposes of explaining how special the rest of the eye is. The two hemispheres give the stomatopod binocular vision within a single eye. The loss of an eye presents little in terms of disadvantage, giving the remaining eye is as effective as if two were present. The midband gives the eye trinocular vision or hexanocular vision, as if two eyes were present. As a military friend said, if only military TADS was as accurate and hence as deadly as the eye of the mantis shrimp. TADS being the targeting system used in attack aircraft. The midband of the eye is an evolutionary marvel comprised of 2 to 6 rows of highly specialized onmatidia. This band allows the stomatopod to see ultraviolet and well into the infrared spectrum. There are omnatidia given over to seeing polarized light, both in a linear and circular format. Research suggests that only stomatopods can see circular polarized light. The onmatidia of the midband gives the stomatopod perception of 100,000 individual colors, using a mere 4 rows of the midband. These rows have 16 photoreceptor pigments, 12 for color sensitivity, and 12 for color sensitivity. The remainder enhancing some colors and blocking others. We humans here see with a pitiful 3 photoreceptor pigments. What does a crustacean need to see using polarized light? Certain parts of the stomatopod body reflect circular polarized light, suggesting a form of communication. I was fortunate enough to be part of the original team based at Sussex University that discovered the ability of stomatopods to use polarized light. If all of that wasn't enough, the stomatopods can move their eyes totally independent of each other, giving them a full 360-degree field of view. It must be evolutionarily advantageous to see both prey and possible predator with the same visual system at the same time. Further, the midband even allows stomatopods to alter the color sensitivity of the eyes, should they find themselves in deeper water where the spectrum of light changes. This means, of course, that they retain their hunting prowess even under very different light conditions. We are forced to use torches to have any chance of seeing at depth. Fact file: the peacock mantis shrimp. Scientific name: Odontodactylus celarus. Pronunciation: Odontodactylus celarus. Origin: Indo-Pacific, a range spanning from Africa to Guam. Habitat, rocky seabeds, always associated with small caves, crevices and burrows. Tank size, 90 by 40 by 40 centimetres. Water requirements, standard marine conditions, 1.021 to 1.025 SG, to 8.2 to 8 pH, to 8.2 to 8.5 pH. Temperature, 25 degrees Celsius. Temperament, a territorial and violent aggressor that would see any tank mate as food. Feeding, small meaty chunks of prawn, fish, crab, squid, cockle and mussels. Availability and cost. The most available of any mantis shrimp, but not an easy find. Prices from around £50 and upward.